All right, I have class. Let's talk about some limits.
Yeah.
Yeah. All right, so if you guys are watching this, you want to enter these all into your calculator as your Y1 through 7. But I'm just going to have you guys pause the video and do that if you want. I'm just going to move on. So here's my calculator, and I have them all in there already. One thing that you guys may or may not know how to do is get the symbols like that not equal. You go right on here to test. And you got a list of all of them, so you just pick whichever one you want. So if you want the not equal, you just press 2. Then you can enter all the stuff in there. So once you get it all in, we're going to look at some tables. You want to switch your default way that you have your table. It says auto right here. You want to switch it over there to the ask. So I'm going to go down here and you just highlight it, press enter, and then take a look at your table, and it should all be blank. You can see you have Y1, Y2, and you'll have more, 3, 4, all the way down to the 7th one. So what we want to do is I want to pick X values that are getting closer and closer to 1 from both sides. So I'm going to start below 1. So just pick a number close to 1 but below it. And then I want to get closer even. And then closer than that. And then I'll go ahead and put one in at 1 just as like a reference, even though we're not going to use it. And then I'm going to start really close to 1 here and get further away. So here you have your list of X values, and the idea is that it's like you're looking at a number line that has a 1 in here. And so if this is 0.9, then I got closer with 0.99 and even closer with 0.999. And so I'm approaching, different color, it's like I'm coming to 1 from the left on there. And then coming from this direction, if I've got 1.1 out here corresponding to this furthest out point, then my 1.01 may be in there, 1.001 in there. So now I'm coming in from the right side. So this whole left-right system is being simulated in the table. Look at these values. You got 4.8, 4.98, 4.998 coming closer. What would you say those are approaching?
5.
5. Exactly right, class of 2.
What about the Y2? Why is that one approaching 3?
It's a different function.
Okay. Yeah.
Coming from this direction, I got 5.2, 5.92, 5.002. What's that one like it's approaching? 5. Excellent. So we're approaching 5 from both directions. If we look at, skip ahead to one of these, it will actually show what's happening. I have all that information on here. So this is what we just saw, that from 4.8 to 4.9 to 4.998, as these X values in here get closer and closer to 1, these are getting closer and closer to 5. As these X values get closer and closer to 1, these are getting closer and closer to 5. So if we look at this in terms of a pattern, and what you would expect for the value of Y1, what would you expect it to be?
Can I write that down?
Yeah, why don't you come up and write it? Alright. That's exactly what I would expect it to be.
Yeah.
It turns out that it's not 5. When you actually look at the value, it's not 5. The value is 10. And we can look back at our calculator and you can see here that the true value is 10, but that actually doesn't matter. As a matter of fact, on this whole table, this line of what happens at 1, it just doesn't even matter. It's only the pattern that you're looking at. And so that's what I'm trying to say here, is that what you expect to be the answer, that's the answer, whether it's actually the answer or not. Kind of a strange thing about limits, but also kind of cool. Freedom from the truth. You just look at what it should be. All right, looking at Y2. So this one, as for all of these, we have X approaching 1 from both directions, but now we're looking at our Y values are actually approaching 3 from both sides, right? So for this one, we said it approached 5. The Y values are approaching 5. For this one, let's say it's approaching 3, right? They're coming to 3 from both ends. We can can look at more. Put both of these on, y3 and y4 on there. Y3 is a pretty simple one, because all of them are 4. What do you think y should be as x approaches 1? 4. Excellent way to put that together. You have to have a keen eye to spot that pattern. You can see what's going on there. It gets a little strange at y4 though. If we look at this one, from the left it's approaching 3. And what about from the right? 4. So it's tough to say what it should be. You know, if I were to say, oh, well, at 4, then y should be, well, I don't know which one to pick. So, you know how I address that?
Does not exist.
Does not exist. Did you want to come write that?
The big D and E,
A
right?
big D and E would be great.
Should I just write it like right there?
Sure. D and E does not exist. This is going to happen anytime that the limits don't match. So you get the limit from the left doesn't match the limit from the right, then your limit doesn't exist. There's one more we want to look at before we look at it mathematically. The same kind of thing is going to happen here. If I look at the values that are being approached, and, you know, on this one's actually kind of just bouncing all over the place. But even if I were to try to say, you know, what it was approaching from this side to this side, for one thing, I don't even have a good guess. It's just jumping all around. But they for sure don't match, right? As I look at both of those, one's negative and one's positive. So, you know, this is another situation where you get it does not exist, is when they, there's just no good pattern from the right and the left. It's not approaching any specific value. So, we've been talking just in terms of what we expect y to be, but we were actually doing some math problems that we can write out like this. For that first one, we said that we were expecting y to be 5. Mathematically, the way you'd say that is the limit as x approaches 1 of the function y1 is 5. So this x approaching 1, this is why we were picking x values that are getting closer and closer to 1. So it tells us x is approaching 1. And then the answer is what is happening to y. So the y is becoming 5. Same thing for the second one, same idea. X is approaching 1. The limit was approaching 3, and the value of the function was 3. For this one, this is the one where they were all 4s. And then these two are where the limit from the left and the limit from the right didn't match. Kind of just the last two things to look at real quick are what happens in y6 and y7. This is just a screen capture from the calculator so you can see. But if you look at these values, they're just getting bigger and bigger and bigger. And so we would say that from the left, this is approaching infinity actually. And from the right, this is also approaching infinity. Well, in terms of what you say then for that answer, it's kind of up to the person, the teacher, or whatever, sits in different classes. The three ways you see it, some people would say it doesn't exist. Some people would say the limit's infinity. And some people would say it increases without bound. It just keeps getting bigger and bigger forever. Over here, it's almost the same. Except if you look at these values, they're getting to be giant numbers, but they're negative. So I'm approaching negative infinity from the left. And positive infinity from the right. And so this one, for sure, is a DNE. Because we've got, anytime we're approaching two different values, either they're infinity, doesn't exist. So I think that's about it.
Kind of like jog across, maybe.
Yeah.
Oh yeah, that's true.
Okay, we should just come in here together. Come in here, students. I'll fade the black right from there.